Another reason that a stream deposits a lot of its load can be that it experiences some sort of rapid change in velocity, a decrease in velocity, where it's no longer able to carry material and it just deposits everything where that happens. And one place that this happens is when streams enter ultimate base level, when they flow out into the ocean or to the sea. And here's two examples here of when that happens. The Nile River, which is flowing from south to north, and here it enters the Mediterranean Sea. And here's the Mississippi River as it flows past New Orleans and enters the Gulf of Mexico. And when that happens, all of the velocity with which the river is carrying its load suddenly goes away. Once the water hits ultimate base level, it no longer has any potential energy left or kinetic energy to move material along, and everything it's carrying just gets deposited. And we can see that area shown in green here. This is where deltas got their name from the Nile Delta, because it looks like the Greek letter delta. And here's the Mississippi Delta, which is sometimes described as a bird's foot delta, because if we look at the Mississippi coming down here, it actually goes off in different directions here right as it enters the Gulf. And that is because it's just, as it deposits material in one place, it literally chokes off that channel, and then we get this distributed channel at the very end of the Mississippi River. And that has been happening for a long time. In the past, the Mississippi River actually followed the course of another river in this area called the Atchafalaya River, and this was a old location where the water draining through most of the United States was building its delta. But over time that moved to upstream from New Orleans here, then off to the southwest a little here, then over in this area here where we see that same sort of pattern, then down here, then along the same channel that we're currently into out to number 6 here, and finally to 7 where it's currently being deposited. So these things are always changing over time. New land is being built at the where the Mississippi River enters into the Gulf, because more and more sediment is being deposited from all over the United States that's been carried by the Mississippi River to its mouth. That same idea of losing a lot of velocity as water moves out of an area is the same process by which alluvial fans are built. So an alluvial fan occurs when water is coming out of a mountain range, and then the water enters into a flat area at the front of the mountain range. And what happens here is that all that material, the material being carried by the river's velocity suddenly goes from very fast in the mountains to very slow as it moves out into this open area where it can flow in any direction it wants. And all of the sediment being carried through the mountains is suddenly deposited right at that outlet of the river valley into the open area. That's what we call an alluvial fan. A lot of times water is easily able to be transported through this coarse material, and we get a lot of water resources in these areas where alluvial fans are. This is an example of an alluvial fan. We can see the place that all this material is coming from is this narrow valley that's cut through the mountains here. Suddenly it comes out into a big flat area out in front, and all of this material that was being carried by rapidly moving water as bed load or suspended load suddenly is dropped because the relative velocity out here is so much lower, and it kind of builds out in one direction and another, and because it forms this kind of semicircular half of a circle fan shape right at the base of the mountains here, we call that an alluvial fan. Alluvium is just something that's being sediment that's being carried by the river. We can see another alluvial fan being deposited here, and smaller versions of those as we move along in these areas here. Probably a bad place to build a road, because of course this alluvial fan is going to be changing over time. But people do like, or have liked in the past, to live on or near alluvial fans because of the supply of water. So in this example here's a community living right on the fan, and the water is coming down through this area here. It's underneath the ground here, but it's not far underneath the ground. And this whole area here are places where the river was actively depositing in the past, and so could also have good water resources available with them.